Today, AI assistants don't just chat, they call tools. The protocol they use is called MCP, and as AI workflows get more capable, MCP traffic gets more complex. Here's what that looks like in practice. A checkout service is failing in staging, and the fix isn't going to come from one place. The logs are in observability, the change is in source control, the patch needs to be generated, the tests need to be run, the deploy needs to happen. That's half a dozen tools, 3 teams worth of context, and a long afternoon. Or, the developer can ask the assistant to handle it. One prompt. The assistant does the rest. But here's the catch. The assistant doesn't have the answers. It has access to tools, and it discovers them as it goes through MCP. The hard part isn't the discovery. It's that these tools live across a whole set of MCP servers, some internal, some external, all different. Watch the pattern. The assistant fans out across multiple MCP servers, internal observability, GitHub, an internal code assistant, internal CI/CD, public and private, read and write, 8 calls in roughly 20 seconds, and the developer didn't have to know where any of it lived. Here's what made that workflow possible. The assistant never had to know where any of those servers lived. One URL. NetScaler routed every call to the right backend, internal or external, with one consistent auth model, one consistent audit trail, one consistent place to apply policy. And for the internal MCP servers that run multiple replicas behind the gateway, NetScaler kept every session pinned to the backend that owned it. Stateful workflows don't survive naive load balancing. Session-aware delivery is how multi-step AI actually works. That's what an MCP gateway gives you, orchestration that scales beyond what a single AI client can manage on its own. MCP makes the tools available. NetScaler makes them work together.